So, and then why don't I go ahead and
Trust me, Pam, you don't want me to show my face.
no, we don't want to see that
It's
face.
better
No.
that I just not.
Yeah, I'm so sorry. That's a drag. Okay, let me share my screen here. All right, so what I wanted to do was make sure that I have a chance to answer any questions you have about the exam itself, what to expect, and then to go through the example problems that I shared with you to see if anybody had any questions. All right. So I'm going to just kind of walk us through what the exam looks like, what it contains. What are the kinds of things that you need to know? What are the logistics for the day? And then we can go into the questions. So, and please just like unmute yourselves and ask a question at any moment. It's a small enough group. I really don't want anyone to, feel like they don't have a chance to ask a question. So there's 4 sections to the exam. The first is just an overview, kind of the overarching information about the Toxic Waste Reduction Act. What are the regulations associated with it? What are your obligations as a planner? The section 2 and 4, you see I have in red, and that's because those are the 2 sections that tend to take the most time. And, so planning accordingly, if you're better at the financial analysis side of things than anything else, you might want to like get that out of the way early, or maybe save it to last, or, pre-planning and process characterization, big part of the exam. So if it's, if that's something that, you want to make sure you leave plenty of time for, because you're less confident in that, maybe that makes sense. Just, plan your time accordingly. Know that there are different sections with different amounts of work associated with them. And those 2 are the 2 that typically take the most time for people. And then there's a section on options identification. Hey, Dan.
Hi, Pam. Can you hear me?
Yep.
Okay, I don't know if I have video. I can try, but
Yep, try if you can. If not, that's all right. So at the end of the exam, there is a lot of information that we provide you. Hey, gotcha. And what I added this year, which hadn't been there in the past, is just an overview of the reporting thresholds. And so including which chemicals are designated as higher hazard substances and which are PBTs. It doesn't lay out all of the PBTs, but it does tell you about the different reporting thresholds, simply because of space. So the feedback that we've gotten, over the years is that that's the kind of thing that you would always turn to a document to make sure you've got it right. And that's true. And that's what we would expect as a planner that you would do, is that you would turn to the guidance and you would turn to the regulations to make sure that you're double checking whether or not a chemical is reportable and at what amount. And there's common conversion factors. There's common chemical information and properties. Remember the whole thing on molar volumes, that's in there. Financial analysis equations and those present value tables that we made use of. And then there's also materials safety data sheets. I need to change that. Associated with one of the problems. So one of the problems is find out, certain information about the hazards associated with the chemical and make some judgment calls based on that information. So those safety data sheets are there. Kyle, you had a question? Yeah.
Is it possible to provide the additional information ahead of the exam just so that we're familiar with what's on it?
I think so. I don't see why not. Let me just double check that with my DEP partners. I don't see any reason not to. But I'll check first. And if I can, I'll send that out as a separate document.
Okay, thank you.
All right. Let me make a note of that so I don't forget at the end of this. Okay. So it's a 60% pass, fail cutoff, which is I think, very reasonable. So it's not a super hard thing, but as I've told you many times, the exam itself, there's a lot to it and it does take time. So if you feel like, you really struggle with a certain aspect of the, the overall aspects of planning, you may want to make sure that you allot yourself more time for those sections. So Lynn Kane and I have scheduled to correct the exams on December 9th. She thinks she'll be able to turn it around really quickly. I just wanted to set your expectations properly and, certainly before the end of the year, but anything can happen, so I just don't want to overpromise. So you will know the results of your exam before the end of the year. Okay. All right. So things you need to know. You really need to refamiliarize yourself with the regulations and the definitions associated with toxic use reduction. So we have in your general materials in the online modules on the online portion of the course, there's a thing called the TUR Primer document. That's a really useful document for you to kind of use to bone up on sort of the requirements and the definitions associated with your planning operations. So you need to know what all the steps in planning are, what you're required to do, and why they matter. Right. And so there's different ways that we might get at that in the exam itself, but you as a planner need to know those things. Certainly you need to know what the 6 TUR techniques are. What are the criteria for reporting and planning? What's the difference between new manufacturing, processing, and otherwise used? What's the difference between byproduct and emission? I don't have that in there, but certainly what the reporting thresholds are, what the roles of the different agencies are. These are the kinds of things that you as a planner need to know, need to be able to, get to really easily.
Where did you say, can you repeat where you said at the beginning where we can find the?
Yeah, it's a document called the TUR Primer, and it's in the online module, the online portion of the course in the general materials section. So what I can do after this is I can send it out separately.
Okay, thanks.
Yeah. It's just kind of an overview of those obligations. All right. So this is the planning process. These are the steps, those things in green, the pre-planning, characterizing your process, identifying options, evaluating those options, reviewing and certifying the plan. Those are the responsibilities of a planner. Those are the things, those are the aspects of planning that you're really, going to focus on as a planner. So you want to make sure that you know what is required in each of those steps. Whether or not to implement, that's something that you can hopefully influence when you make your recommendations, but it's really not up to you. Implementing the plan, measuring success, those are things that are facility level are happening, but not necessarily a planner's responsibility. Here's this graphic you recall about the difference between manufacturing process and otherwise used. What's the basic? How would you define it? How do you define it? Just instead of reading what's on there, what's the difference between manufacturing processed and otherwise used? You guys need to be able to spit that out really quickly.
If you're manufacturing something, you're creating a substance. Processes, you're using it and it's intentionally incorporated in the product, and then otherwise used is other. Yeah. Not intentionally incorporated into the product.
It's really not intended to go into the product. And so, yeah, and it's really essential and that that down flat. You remember we did example, questions about is it or is it not reportable? Well, that's making that distinction first between whether it's manufactured, processed, or otherwise used is the first step in deciding whether or not a chemical being used in a facility is reportable. If it's reportable, it's something that has to be incorporated into your plan. So this is a very, very important kind of first step aspect of any planning operation. And you as planners really need to be able to make that distinction. You will certainly see problems that talk about that. So these are the reporting thresholds. As I said, we've provided those on the additional materials for the exam itself. But the point is that anything that's designated a higher hazard substance, the threshold is 1,000 pounds per year. If it's a PBT, it's even lower. So what are some common PBTs that that you may see, things like lead and mercury. Lead is 100 pounds per year use. Mercury is 10 pounds per year use. Dioxins are 1/10 of a gram per year use. So those are the super bad guys. But so that will be provided to you. Do you guys, well, we've also provided what are higher hazard substances? What are the listed higher hazard substances? So that should help you. And again, as I said, that's the kind of thing as a planner, you're going to be turning to regulatory information to make sure that you've got that right. So that's why we felt like it was fine to share that information. All right, so you need to know how to create a process flow diagram and what needs to go into it. You're going to be seeing word problems similar to what you got in your practice problems, from which you need to draft a process flow diagram, right? And so that just means carefully reading through what is happening and making sure you understand it, and then just mapping it out. You need to know what a production unit is and is not, what units of product are and why they matter. You need to, be comfortable making unit conversions and really making sure that you're tracking your units as you do calculations. And again, when you are doing calculations of any kind, when you're doing any aspect of the exam, if you don't include your units in your calculations, we won't necessarily be able to tell whether or not you knew what you were doing, whether or not you were, really doing the right thing. And so it's harder to give you partial credit. So please include units in any calculations that you're doing. If you are making an assumption of any kind, write it down. And that, so if you make an assumption and it's a bad assumption, but based on that assumption, you did everything right from that point forward, you're going to get partial credit for it. Okay. So, you need to know how to do a mass balance. All right. And you need to really be able to calculate the difference between byproducts and emissions. So you need to know what the difference is and how to calculate them. And again, we had some nice examples of that in the problem set that I sent to you. So, this is a typical kind of a, process flow diagram. And it was an example that was in the example set that I sent you. So it's, it's a series of blocks that show, the main process operations within a production unit, that show how the product is flowing through. It shows where there may be byproducts or emissions. It shows the boundary of the production unit itself, as well as the boundary of the facility. So this is a good example of where, there is an additional process associated with this production unit, the wastewater treatment. Wastewater treatment is never incorporated into your production unit. So it would be outside of the production unit boundary, but part of the facility. Okay. So what else would you expect to see in a process flow diagram? is what I read.
Quantities,
What's that?
chemical quantities.
Yep, quantities, task numbers, production unit identification. Well, this says production unit A, so that's how they identified it. When this was revised, right? So in your plan, you are expected to be updating or revising process flow diagrams every cycle. Or, or at least making, in saying that you have reviewed it and it is still the same. So, that would be a revision date. That's an indication that you're paying attention to how things may be changing. So, you want to be showing what chemicals are there, what are the amounts and what is going out. So this is a good first step. The guidance document provides, that checklist that tells you what needs to be in the planning itself, something for you to kind of be looking through that guidance document again. There is an example process flow diagram that is a good thing to just take a look at. So byproducts. Byproducts are those things that leave the production unit boundary, that envelope that we show on our process flow diagram. And so that means that they're non-product outputs that are leaving the production unit before additional handling, transfer, treatment, or release. Okay. Whereas emissions are what are actually leaving the facility boundary. So they are byproducts that are then moving on to leave the facility boundary. So they are being emitted through the air, water, solid waste, or offsite recycling. So it's what goes outside that facility boundary. Important that you have really clear on that. And one of the things that we've seen over the years is that that's not always clear. So does anybody have any questions? Has anybody seen an example where it's not clear what that difference is? All right. So mass balancing is important, right? Making sure that what goes in equals what goes out. And that's an important aspect of what you're doing to make sure that you've understood everything that's happening in the process. And inputs don't always equal outputs, right? There are circumstances where a chemical is consumed within the process or transformed within the process. When you're talking about a compound, the total weight of the compound can change. So with a compound, you're reporting the amount of the compound that's going in, but you may only be reporting on the emissions of that chemical itself. Like, so in this example, lead sulfate versus lead, even though it's still contained in lead sulfate. Compounds can be really tricky. And so when you're actually out there doing planning and reporting, if you're doing the reporting, you want to really make sure that you understand those nuances. You're not going to be tested on that kind of a nuance in this exam, because the exam is really more focused on the planning aspects of it. Understanding whether, doing your materials accounting and materials balancing is important, but it won't get into those kinds of nuances. And then, a chemical can be integrally recycled, which also might make a difference between what goes in and what comes out of the facility. So, and we'll probably have something around integral recycling in there. We had example problems that I shared with you. So questions about material balancing? Okay. Options identification and evaluation and how to interpret that information. So you want to be thinking about whether or not a chemical whether or not the option you're considering is actually toxic cease reduction. Is it TUR, right? If you're going from one toxic chemical to another, Is it TUR? You want to be able to respond to that. You want to know that as a planner. That's one of your first questions. Is it safer? Is it technically feasible? Is it economically feasible? That's part of what you need to be able to determine as a planner. You need to be able to interpret the hazard information that you gather on chemicals and on the alternatives. That's where those safety data sheets will come into play in the exam itself, is actually that interpretation part. And then there's the financial stuff. So basic financial definitions, understanding the time value of money and how you can look at that in a way to determine whether or not an option seems like it's a good idea. The cost of toxics is really important. Understanding what it costs a facility right now to use a toxic, being able to determine that is important, because you use that to compare the alternative to decide whether or not it seems like it's a good option. And really making that case to implement a plan. You need to know what, you need to be able to really distinguish what are the things you can say to the decision makers to help them understand that this is an option worth considering implementing. And that's the extent of your responsibility. It's up to those decision makers to decide whether to go forward or not. And then there's those ethical requirements for you as a planner, and for the plans themselves that you need to really know that you need to know as a planner. All right, so the cash flow timeline can be a really useful tool. Some people are super comfortable just using the calculations to determine what the present value of something might be. Some people need a more visual cue like this. So when you come to the financial side of things, you want to kind of map it out like this, that can be really helpful. So those outflows are what is the the capital expenditure, and then those operating costs year by year. The inflows are what are the savings, and then you can apply the discount rate and the number of years that you need to project out for to get a sense of the net present value of a project. So you can use the table to do that. You can use calculations to do that. Mapping things out like this, I find, can be really helpful. So we can talk about some of the financial problems that we had in the example problems I sent around. So we're going to start at 9 o'clock next Wednesday. All right. It'll have to be complete by 4. Everybody will be complete by 4. I just want to say that we will get you lunch. And so what I'm going to do, and I need to know, so for everybody on the call right now, are you planning on being at the exam? I have Rachel, Izzy, Bethany, who's not here, Carrie, Kyle, Mike, who's not here, and possibly Joanne. Anybody else? Did I miss anybody who's going to be at the exam? Dan, I know. And by the way, I want to point out, Izzy took the class last year and wasn't able to take the exam because you had a medical procedure. And so she's taking it this year. So that's who that strange person on the sidebar there is. She's really not that strange. Well, I don't know, Izzy. Okay, so we're going to send you information on parking. And parking is free. You have to walk a little bit to get to our facility. We'll have these little sandwich boards out there to kind of direct you to our office. It can be a little confusing. We're in the Boot mill buildings, and it's just, it's kind of it's a mill building area. It's they all look alike, and it's kind of sprawling. And so we'll make it as easy as we can. You all should have my cell phone number so that you can contact me if you're having a hard time finding, our office place. But there's my cell phone number. You could just write that down. Feel free to text me if you're turned around, and we'll get you there. So DEP requires that all electronic devices are powered down during the exam. You can use a non-web connected, non-programmable calculator. We have old school calculators. I mean, who has their own calculator these days? I think most of us use our phones. So we have calculators that you can use, or if you have something that fits those criteria, then that's fine. But DEP requires that all electronic devices are powered down during the exam. Again, when you're going through the exam problems, make sure you show all your work and provide the units. Do the best you can to make your work legible. We are going to give you partial credit. This is not about like making sure that everybody passes, right? Although I expect you all to pass and want you all to pass, it's about making sure that we see that you know what you're doing. So if you go down a rabbit hole, but your thinking is still in line with where it should be, you're not going to get like 0 credit because you went down a rabbit hole, kind of thing. Always state any assumptions that you might be making, or like how you may be interpreting a question. If you find yourself struggling, just do that. We give you plenty of space on the exam itself, but we'll also give you extra paper if you really want to just kind of, if you need to use extra paper to make sure that you get it all straight. I know sometimes I need to start all over again once I've kind of started jotting things down. So that's fine. We'll make sure you have what you need. Lynn Kane will be there. I will be there. If you have questions, we can try to answer them. If you have a question that everybody should hear the answer to, we'll make sure that that's what happens. But for the most part, you're just going to be hunkering down and doing your work. I'm going to send each of you a menu from a local sandwich shop, and we'll get you lunch, and we'll just bring it, and we'll try to minimize distractions for you. But there's a bathroom right down the hall. You are all adults where we expect you to, just do your work and get it done, and we'll help you where we can.
And we Pam, on the 4th section of the exam, it says 6 questions. How many points was that?
Let's see if I know how to get there really quickly. Haha, I do. So it's
6 questions and 53 points, really?
For the financial analysis section.
Okay, thank you.
Pam, is it okay if we just bring like snacks and stuff to have with us? Is that cool?
Yeah, it's absolutely cool. And if
Okay.
we will probably have some snacks available as well. We'll have coffee and tea and water. Yeah, I mean, we definitely want to make sure you guys aren't like, completely just configured, whatever, when we're doing this. So we'll do what we can for you. Any other questions about sort of the logistics? All right. So what I wanted to do is spend a little time going through the exam problems, and well, I think that the amount of work that's in the set of exam problems that I sent you is similar to what you can anticipate for the exam itself. They're not obviously the same questions, but it's a similar level of effort. So first of all, let's just start there. How does that feel?
That's okay. There's some questions that I was unsure about and still have questions on, but we can address those as we go through.
Yeah.
But overall, it seems manageable.
Okay. Good. Good. Okay, well, let's do that. So, the questions are like basics, and it's kind of laid out similar to what you will see in the exam itself. Basics about the act and about planning, more on materials accounting and process characterization, and then more on financial calculations. And not necessarily a lot in here, I have to say, about options identification and evaluation. So I just realized that. Huh. All right, well, so let's just look at that. So the true false questions. So toxic use reduction is an important provision of the 1970 Clean Air Act. True or false? No, false. Just unmute yourself so you can I can hear you. Yeah, no, it's not. It's part of EPCRA, right? And so I will send you the solutions afterwards. What about TUR Planner is responsible for overseeing implementation of the plan?
No.
False.
False.
Right, it's false, right. The federal TRI is modeled after TURA? Nope.
False.
Vice versa, in a way. TUR plans or plan updates must be submitted to DEP every 2 years. Trick question.
It's every year, in a way.
Nope. It's plans or plan updates must be created every 2 years and kept at the facility. A summary of the plan update, it must be submitted to DEP.
Okay,
Trick question, but it's important to think about. Reporting has to be done every year.
okay,
Planning is every other year. Every other year, you will be submitting to DEP a summary of your plan or your plan update. That is publicly available information. But your plan itself, you can keep on your facility. It is not necessarily public information. DEP could request that you submit it when if they decide to do an audit. But they may, you may never have that request. So that was a trick question. There's not a lot of I don't think there are trick questions in the exam itself. All right. So I really, I'll let you know. So production unit, the quantity of byproduct will always equal the quantity of emissions. No.
False.
Right. Right. There's circumstances where it's not the same. So really important that you know the difference between byproduct and emissions, and that you can read a problem, you can be given information and really discern the difference. So the 6 TUR techniques, you all know what that is, right? Yeah. All right. You certainly need to know what those are. So the name of the act passed when Superfund was amended is what? EPCRA. And the 3 categories of thresholds used to determine whether a facility must report?
Manufactured, processed, otherwise used.
Right on. So annually, you're submitting your Form S, your TUR report, and it's due July 1st of every year. So you do want to be able to define unit of product, production unit, byproduct, and de minimis exemption. Does anybody have any questions about those definitions? No. Is there a de minimis exemption for a PBT?
no,
No. So that's an important caveat. As a planner and as a reporter, you might, need to know that. What are those 3 standards that planners are required to adhere to?
Good engineering practices, standard accounting, and preparing in good faith.
Thanks, Carrie. Exactly. Some years I beat that into people's heads too much, and some years I don't. I feel like this year I didn't overdo it with you guys, but you got it right off the bat, so maybe I did. So you know what a PBT is, persistent bioaccumulative toxic. Those are the really bad chemicals. And when EPA identifies a chemical as a PBT, it automatically is identified as a PBT under TURA and subject to those lower reporting thresholds. So after you pass the course and the exam, what do you need to do to receive and maintain your certification?
I was unsure about this. Is it continuing education credits?
In order to maintain your certification, you need to maintain a certain number of continuing education credits. And that varies depending on whether you're a general practice or a limited practice planner.
Do you need that to receive the certification?
To receive the certification, you need to apply to DEP and pay a fee. And that is my cat's tail. And I don't think that there's anything else. I think, I don't know, maybe Rebecca's not still on. I was going to see if she, yeah, no, pay a fee, apply, pay a fee, go away.
Is adequate work experience part of it?
So eligibility, so you have to be eligible, right? And your work experience, your education, those all go towards determining whether or not you're eligible. Each of you are responsible for doing that. So I, in the past, have had people go through the course, take the exam, and then discover that they're still not eligible because they don't have enough relevant work experience. And I really, I hate for that to happen. So, if you are at all concerned or, wondering whether or not you are eligible, there is a document the DEP has that you can use to submit to them for your certification, and that'll sort of initiate the conversation. I used to just tell people to go ahead and call Walter Hope, but he would prefer that you go through that step first. So if you are in doubt at all, let me know and we'll walk through that and we'll figure it out. I don't think any of you have a problem there. But yeah, anyway, enough said. Okay. So let's go through now. We got a bunch of questions that are more about the materials accounting side of things. So Sally's Silly Circuit Shop. This was not my name. I bet it's fun. So first of all, when you're calculating how much chemical is being used and how it's being used, you need to know how it's being used. So for TCE, in this example, how is it being used?
Well, it doesn't tell you how much. It says it's used in 3 different production units, but it doesn't tell you how it's being used. So
Right.
I'm going to assume that, or this is one of those assumptions I have to write down, that this is actually it's a process and not a manufacturing.
Well, yes, you definitely have to write down what you're going to assume. And because it's a volatile, solvent used in the manufacture of printed circuit boards, and because we have a lot of information on the evaporative losses associated with it, I think that we can assume based on that information that it's probably otherwise used, not processed. It's really asking you to kind of like take a step back and go, okay, first step, how is this being used? All right. Now, if you say, I assume it's being processed, and then you calculate how much is being used, and it doesn't meet the 25,000 pound per year threshold, which goes along with being a processed chemical, we'll still give you partial credit for, how you make those calculations and if you did it correctly. But you won't get full credit because that is, that assumption would be wrong. But you won't get dinged too badly, right? Because you've said, this is what my assumption and why.
Pam?
Yeah.
Because the evaporative losses, offsite recycling, and offsite energy recovery all equal 100% for every production unit, can that be an indicator that it's otherwise used? Because obviously none of it is ending up on the product.
Mhm.
Okay,
If it were processed chemical, I would assume that I'd have some information on how much goes into the product,
okay,
right? So we don't have any information on how much goes into the product. In fact, we have a lot of information indicating that it's released somehow. So it's a safe assumption that it's otherwise used. Right. So, so first thing to remember is that specific gravity is a relative number, and it is basically telling you what is the density of the substance you're looking at in relation to the density of water. So if a specific gravity is less than 1, it is lighter than water. It's less dense than water. It would float on water. If it's a specific gravity higher than 1, it is more dense than water. It would sink. So in this case, TCE is a solvent. It is less dense than water. And so you go through the calculations and you determine how much TCE is being used overall. What did anybody get on that?
12,540 being otherwise used, pounds being otherwise used.
Did somebody get a different number? I got a different number, but not radically different. So one of the things that happens, and here's a great example of why you would want to make sure that you are writing out, your work and showing your units. It may be, Kyle, that you were using significant digits differently than I was, and that can affect your final number, right? So, yeah, I mean, you take the gallons of TCE in each unit, multiplied by the specific gravity, multiplied by the density of water, right? To calculate.
I got
pounds.
12,818.
Yeah, that's what I got, Joanne.
Yeah, it might have been rounding. It seems to be the right ballpark, and the process sounds the same. The steps are there.
Yeah, and it's also, possible that you just, calculated, you hit the wrong number or something. So all of those, this is why it's so helpful to write out your answers. So yeah, so what you're doing is you're taking the gallons times the specific gravity times the density of water, pounds per gallon, to convert from gallons to pounds. Adding it all up, this is my answer. Now, how much of that is byproduct? How much of what's used is byproduct?
All of it.
All of it.
Yeah. And bear in mind, I got this answer, but I had to look it up. I had to, look up how to do it again and all that stuff. It didn't come that easy.
Well, this is
Been a
why we
while.
do the example problems. And this is why you really should be boning up beforehand. And this is the kind of calculation that you need to be comfortable with,
Mhm.
right? As a planner. You need to be able to look at the information that you're given and do a material balance, do your materials accounting. So this is an example where we're looking at what would be the reporting implications associated with a process. And that's the first step towards determining whether you have to go through all the planning steps, right? I know that in many facilities, the person responsible for the annual reporting is not the planner. And that can be a problem. So as a planner, you want to make sure that you're in touch with the person who's doing the reporting. You want to make sure that you agree with what they've done, that you understand what they've done and why, right? So it's just a reminder as a planner. So what about Jones's Rubber Company? So here's an example where we're given a little bit of information, right? So first of all, what we have a component of synthetic rubber, which is reportable, this 1,3-butadiene. So is that manufactured, processed, or otherwise used?
Processed.
Processed.
Right. So in this case, we can assume it's processed because it's a component of the rubber itself, right? So yeah, so processed. So what did folks get with respect to how much of that chemical is actually being processed?
15,500 pounds.
Yeah, you take the pounds of rubber and multiply it by the percentage of that component. And so is it reportable?
Yeah.
It's not reportable, right? Because for a processed chemical, that's a 25,000 pound per year threshold. So good. All right. This
I have a
next,
question. I looked up the butadiene and I thought it was 100-pound threshold.
the 1,3-butadiene,
Yeah, is that wrong?
you know what? Maybe not. So I am going to look. So if it was a 100 pound per year threshold, it would be a PBT. Right? And so where did you go to look for that? I don't see it on my list of.
Yeah, I don't see it on that list. I just looked under the list of lists that's just the RCRA, all that list there, and I just put that number in.
Okay. So right. I'm just trying to think. So in the did you guys just see what I pulled up? Which was the exam? No, you didn't see that. Okay. Like I don't. However, what I'm looking at is the additional information.
Okay.
Are you seeing that right now?
Yeah.
You are. So that is the additional information that
Oh, okay.
that you'll get, and it tells you the higher hazard substances, and it's not a higher hazard substance. It tells you that it just calls out those PBTs that have the lower reporting threshold, and the rest are 100 pounds per year. I don't think that that chemical is a PBT, but if you in the exam, it will tell you if it's a PBT, or it'll give you a reason to believe it's PBT. So if you are assuming it's a PBD, just say, I'm assuming it's a PBT.
Okay.
Yeah. All right. Thanks for asking that. So this next question around shipping, purchasing, so they lost all their data. Now they have to calculate and estimate how much of the xylene is released from a spray booth. So here's where we start to look at, so this is where, it can get tough, right? So what's the data we have? We have the volumetric flow rate. We have cubic feet per hour from the spray booth. So right there, I know that I have a volumetric number that I can use, that I can probably use. We have the concentration of xylene in parts per million, right? So I have a concentration. I can now calculate, I can use that to start to calculate the pounds, right? Because I know what the molar, the molecular weight of xylene is. So you need to know these things. And let's see, does it say, yeah, does it? Oh, it says, yeah, the molecular weight of xylene is 106.7. So I know that. And then I know how much that equipment operates for. So, here's an example where you're looking at what's the information I have, And how can I get to the information I want? The information I want is pounds per year. So I've got a molecular weight, I've got the molar volume, I've got how long something operates, I have the volumetric flow rate, and I've got the concentration of xylene in that airstream. So, so then you go about and you try to figure out what is the pounds per year. I think what I can do is,
I came up, did anyone get, I came up with, did you want an answer?
yeah, please.
I came up with 1,138 pounds.
Yeah,
Yep.
good. Let me just see if I can, do you see that now?
Yeah.
What are you seeing so these are the answers. So that's what you're seeing, right? Because I pulled it up.
Yes.
Okay, good. All right, good. So that works. So yeah. So right. So you take that's what we got. And again, you know, there's a significant figure issue there probably, which is why there's a difference.
Yeah.
Don't worry about that too much. But you're taking the molar weight times parts per million. So it's 15,000 parts per million parts. And then you can use the volume, the molar volume, which is 22.4 liters per mole, to convert molecular weight to grams per liter in the air. You see that? And then I can take that grams per liter and just convert it to pounds per cubic foot, like, you know, convert grams to pounds, convert liter to cubic foot. So now I have pounds per cubic foot. Why did I do that? Because I know what the cubic foot, the volumetric flow rate is. So I can take the pounds per cubic foot times the volumetric flow rate and the number of hours it operates per year to calculate the pounds per year. So, you know, from an exam taking perspective and just from like I have bits of information perspective, what do I have? What do I need to know? How can I get there? And it's really important that you're looking at you're including your units as you go so that you don't skip a step. If you forget, say, to convert liters to cubic feet, you'll get a different number. And if you don't show that, then we might not know why you got it wrong. So it's hard to give you partial credit for it, right? So questions about this? There are people who spend a lot of time dealing with air emissions who have no problem with that. And there's the rest of us. So questions about that? I'm going to send this to you so you don't have to write it all down.
Okay.
Yeah. All right. So then we go on to this next problem, which is about the, you know, calculating the byproduct from these processes. So I pulled up the process flow diagram that you were given. And so you want to calculate the total byproduct for this production unit. What are the inputs to this production unit? The inputs of chemical.
Oh.
Let's look at the labels that we have. What do we have for inputs of chemical?
Just the products going in.
Yeah, we just have the product going in. All right. So we haven't even been given that information. So what's the output? What are the byproducts from this production unit?
Byproducts versus emissions.
Well, yeah, what are the byproducts?
W1.
W1, right? Because W1.
W, S1, W1, A1,
Mm-hmm.
And
And then
S-
S3,
yeah. Yeah,
right?
S3, A1, S1, and W1.
Right, right. 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 So, yeah. Yep. So that is 2,200 pounds. People get that?
Yep.
All right. So for the next one, now we have incorporated a recycling unit integral to the production unit to recycle that solvent. So what is the byproduct? How do you calculate the byproduct for this example? What are the elements? Byproduct from production unit A. It's still A1.
Yeah.
Still S2, right? It's still W1, right? No, you said no, Carrie. Why?
I'm sorry, I thought you said S2, not S1.
I
Yeah.
might have said S2 and I meant S1. Thanks. It's still S1.
Yes.
You're right. It's not S2 because S2 is not part of the production unit, right? So it's A1, S1, W1, and R2, right? So this is the recycle waste. This is, the waste stream from the recycle unit.
Did we skip 12B?
Yes. Yes, we did. But let's stick with this since we're here.
Oh, that's funny. I was like, what is going on? Because I was on.
Yeah.
Okay,
It's my
great.
fault. My bad. I don't
There
know
we
how
go.
I did that, but here we are. Yes, we did. So sorry about that. So yeah, so the byproduct A1, W1, S1, and R2,
Yeah,
right? Which
Yep.
gives you a lower number. Because we're recycling it, our byproduct is reduced, right? From the 2,200.
great.
And the 2,200 was what was the byproduct, whether or not it has a recycling unit, non-integral or no recycling unit. Right, let's go back to that where I should have been. No, wait, I guess I skipped it all together. Looks like the heck. Yep, I skipped it all together, sorry.
Yeah.
But yes, when
Yeah.
you're not integral to the production unit, it doesn't impact what your byproduct is. Right? So if this recycling unit is outside of the production unit, the production unit boundary, then it's R1 that you're looking at. Right? And that's the 1,000 pounds.
Yep.
Yeah. So it's the same. Sorry about that confusion. Okay, so really important to pay attention to where that production unit boundary is and get that straight. So chemical calculations, molar weight of acetone.
58.
This last one. Okay, so you have, so that it's 2,200 pounds for this figure 12B as well? Because nothing
Yes.
changed? Okay.
Yes.
And so the important thing, because I mess this up all the time, the important thing is to look at the boundary and look at what's leaving the actual boundary versus the facility boundary or the production unit boundary. So it looks like
When you're calculating byproduct, you're looking at what is crossing the production unit boundary.
okay.
And so the example I'm showing you, the recycling unit is integral to the production unit. It's inside the production unit boundary.
Mm-hmm.
So you have a different number. If this production unit boundary was up here, then R1 would be the number that you would be using for what's leaving the production unit boundary.
Okay.
Really important byproduct is what's leaving the production unit boundary. Emission is what's leaving the facility boundary. So in this example, the emission from the facility is A1. See, I'm just going around the facility boundary. S1, W2, S2, and R2. So that's, that's why it's important to kind of really be very clear about where those boundaries are. All right, so let's look at the molecular weight of acetone. So first of all, you would have to know what the formula for acetone is, right? Which, who knew what that was?
We were given the formula.
Okay. That's
But
why.
we weren't given any other information. So are we expected to memorize it, or is this where it would be on that additional info sheet?
On the additional info sheet, one of the things on there is a periodic table.
Good, okay.
Great, okay.
So you could get the molecular weight for each atom.
Mhm.
I don't think you have to do that in the exam, but we're doing this here because we want to make sure that you kind of get this concept. So you would take the molecular, the formula and apply the molecular weight. So you'd calculate the grams per mole for the molecule using each atom, right? So we have 3 carbon atoms. We have 2 here because it's part of this parenthetical,
Yeah, I think the
aspect.
question, I think I had to look up the weight of each, of carbon, of hydrogen, because
Yep.
I didn't have that off the top of my head either.
Nobody
Really?
does. I mean, no, I shouldn't say that. Somebody does, but we don't. No, you're not
Yeah.
expected to. You'll have a periodic table provided if you need to do that. Okay. So you just go through that process. You just calculate the molecular weight for each atom and add it up. So 1 mole of acetone should be 58 grams.
Okay.
Right. So what about the pounds of 0.433 moles of calcium nitrate? It's kind of the same thing, right? You're going to calculate the molar mass by looking at each of those elements, each of those atoms. What is the molecular weight of each atom? How many of each of those atoms do I have? Adding it all up. So 164 grams per mole. That's the total molar mass, right? Did you get that? And then you just multiply. It's not 1 full mole. It's less than half a mole. So 71 grams per mole. Once you have grams per mole, you can convert it to pounds by applying, by just converting grams to pounds. I just want to make sure that I didn't skip any information here.
When you get 71 grams, that should be 71 grams, not grams per mole, because the moles cancel out.
Right. That's why. Yeah, you're right. Thank you.
Okay.
That's exactly right. The moles have canceled out. So it should be 71 grams. And then you just convert it to pounds. Yep. Thanks. I will fix that. All right. And then converting density to specific gravity. Again, we talked about it is that the ratio, the relative density to water, right? So and water is 8.34 pounds per gallon. You'll be given that. That is a number worth memorizing.
Mhm.
So at standard temperature and pressure, the density of water is 8.34 pounds per gallon. It's also 1,000 grams per liter. Easier to memorize. So, either way. And then you're just going to, calculate what the density of that substance is. So we know that it's 0.88 specific gravity. So times the 8.34 gives you 7.3, right? So that's all I have on my slideshow, but that's okay because I have, as we saw already, more solutions. So, right. So density of substance, being able to calculate the density of the substance is really important because it helps you get to what is the pounds, and that helps you to determine, what your reporting obligations are and whether or not you're able to account for the full inputs equaling the outputs of your production unit, right? And make sure that you're not missing any data. So, there's more examples in there, calculate the mass in pounds of 30% by volume toluene and 70% perc in a really nasty solvent blend. So it's just using what we know. We know, it's a percent by volume. So it's just a direct, application to the gallons, and then you convert it to pounds using their specific gravities. Bing, bang, boom. Questions on that? Did everybody get these numbers? 70, essentially 2,700 and 11,400.
Yep.
So there's more and more. Let's see. Are there any questions, specific questions that you want to walk through? Because I will be sharing all of this with you.
Yep. The one that you have up on the screen, I didn't know how to go about.
Okay. So calculate the mass in pounds of 30% by weight of toluene. So we have this company, they're using, 1,225 gallons of degrees, disgusting stuff. We know what the specific gravities are. Calculate the mass in pounds if what we're given is a percent by weight. So then you have to convert the gallons to pounds, and before you apply those percentages. And that matters. And sometimes we miss that you may be given information in a percent by volume versus percent by weight, like in a safety data sheet. So it can make a difference. All right. So first you have to calculate the density of the mixture, which is the mass per volume. So we know what the volume is, right? And based on the information we know that we've been provided, we know that if we had 100 pounds, 30 pounds of it would be toluene and 70 pounds of it would be perc, right? So if we had 100 pounds of the mixture, and this is just, I'm not saying we had 100 pounds. I'm just saying, let's figure out what the relative pounds are. So if we had 100 pounds, what was the volume of that mixture? So there you're going to be applying the specific gravities and the density of water to convert from that 30% to what the kind of the volumetric percent would be. From the 30 pounds of toluene, it converts to 4.1 gallons per toluene using these calculations. And you do that for perc, and you add them up. So if we had 100 pounds of mixture, that would be the same as 9.4 gallons of mixture. So 100 pounds per is 9.4 gallons. That gives you a pound per gallon, which is a density, right? And you apply that to the actual number of gallons that you have to figure out the actual number of pounds that you have. So this was all sort of a hypothetical. Let's figure out, what is the relationship when we're looking at mass of toluene and perc, and then using that to apply to the numbers that we have.
Okay, that makes sense. It's that hypothetical first part that I think I got tripped up on.
Yeah. And understandably, did anybody do it differently?
Well, I'm just curious why you used 100 pounds instead of just going with the 1225.
The 1225 is gallons.
It's gallons, right? So if you did your percentage by gallons and then convert gallons to pounds, that's you're saying is incorrect?
Well, how would you convert the 22, the gallons to pounds?
Well, of the 1225, 70% of it is going to be perk and 30% of it's toluene.
So of the 1225, a percentage of it is perk and a percentage of it is toluene, but these are percentages by weight. And this
Okay.
is volume. And
Gotcha.
so volume and mass
You can't mix
aren't
them.
always equivalent, right?
Right.
Because of the difference in densities. And so you had to go through these
So using
gyrations.
100 pounds is a sort of a standard trick to figuring that out.
It's a standard trick to figuring that.
Okay, that's what I didn't understand. Perfect. Okay.
And my question is if anybody did this differently, because this is tricky.
I didn't even get to this.
Well, you're sick, so we're gonna give you, we're gonna give you, we're gonna give it to you.
Okay.
So then, then you get the weight of the mixture. Then you can apply the 30 and 70 to figure out how much is toluene and how much is perk. It's a little convoluted. I agree. So it's an example of just like, needing to kind of work the numbers to figure out where, what and how you can use that to determine what you have to report on.
Mm.
Right. Oops, what did I do? Back to this. All right, sorry. So we're seeing this again. All right. So these are otherwise used solvents. They're used as a degreaser. If something is a degreaser, it's a cleaner, it's an otherwise used chemical. That's just always true. All right. So volumetric flow rates again. So this is something that, you want to take some time to look at. How do you calculate emissions? And again, like I said, some people do a lot of air reporting, and this is very easy for them. And then there's the rest of us. So the concentration of xylene in the vent gas in pounds per cubic feet. I know what I want, and I know what information I have. I have the volumetric flow rate. I have the I have the percentage. We already went through this, didn't we? I feel like we did.
There are a few like this, actually. I think there's another one that comes up that's similar.
That it's similar. All right. So we did go through the 15,000 pounds per gallon in the same cubic, volumetric flow rate. So it's gone through this again to give us pounds per cubic feet, and then we apply the days per year. All right. So we already did that one. So I just want to take a look at time. We're not going to get all the way through all of this. I'm going to share this with you. I want to find out if there's a specific question that you want to talk about together.
For 18, where it has 300,000 pounds per year going in, I got confused because it says the company used 300,000 pounds of the paint, but we know later on that 40,000 pounds were recycled. So I wasn't sure if that input should actually be 260,000 pounds.
So this is what we drew. So we know that there's 300,000 pounds going in there, and we know that some of it is being recycled back. So that's inside the production unit boundary. So 55,000 is recycled and 40,000 is returned. So there's going to be 15,000 coming out. It's actually being emitted.
So like in the furniture paint application process itself, they're actually using like 340,000 pounds.
So.
I might be overcomplicating it.
I see what, yeah, I see what he's saying, because you're recycling some of it, so it's being reused, or even more is being used.
Right, right. And if they weren't recycling part of it, then this number would probably be higher,
Mhm.
right? So that they would be able to do what they're doing. So we don't have a lot of information about what's going on in there, but we know, we've been given some, very clear, we've been given a lot of information. So that's a good question, though, and it is something to think about. So much is being recycled, and of that, some of it's being returned. Okay, recycled, returned. Just start simple and then see if this is all making sense, or if you need to kind of go back and read through it again. Did you miss something? But yeah, you don't want to overcomplicate things as you start, right? So did anybody else have a question about the process flow diagram? Because you will be asked to draw process flow diagrams based on something like that.
How many of them do you think we'll have to draw?
Well, as I said, I don't know, one or two, but it's enough,
Oh, I'm sure.
Yeah.
Could we be showing the pounds of cobalt on the diagram?
The 50% cobalt. Start with the raw numbers that you have.
Right.
So I would start with the paint.
Okay.
I think it's important to start kind of basic and then dig in as you need to, but not more than you need to. So, you're going to use it when you're calculating the amount of cobalt that's processed, right? And it's processed, right? It is being painted onto the furniture. So it's intended to become part of the furniture. It is processed. So it's 150,000 pounds of cobalt. And what comes out? Well, it's only this 15,000 pounds that's a byproduct, because the 55,000 pounds, bulk of that is actually being returned to the application process. So it's only the 15,000 pounds that is a byproduct, and the rest is shipped in or as product, right? So this is the amount that's leaving the facility, leaving the production unit on the product itself.
And
So
if they-
that's,
Could
if
we
they
go
ask-
through a financial one next,
Yes.
if that's okay?
yeah, absolutely. Which one?
23, I think the car one.
All right, you have to buy a car. All right. Okay. So what you're looking at here is, what is the difference of buying this versus that? And then what is the payback of that difference? Right. So one costs more than the other, but I have savings that are different. So what is the simple payback? So you're not looking at the absolute numbers. You're looking at the differences there. All right. So it costs 3,000 more, but $60 less per month. All right. So when we know that we have a 4% annual discount rate, right? So the simple payback period is just the capital expense, that difference over the operating expense difference. So
And I had a question for that one, because, sorry, I did that right, but I wasn't sure if I should use the 4%, because I didn't know if that was for the Chevy, if they invested the money in the Chevy. So I said, well, because this was for buying the Ford.
right. So simple
Oh.
payback doesn't consider the time value of money. It doesn't care about whether you're going to be getting interest on
Oh,
it.
no, I
It's
think I
just-
was jumping ahead to
Okay,
B, to the answer, to the
Okay.
question in B.
all right. So it's not about the Chevy or the Ford, it's about the money. Right? So, and trying to decide, is it better to pay more money up front or not? The variables that I need to think about are there operating savings associated that, differences that I need to account for? And if I didn't pay that money, that difference of money up front, what could I be getting for it now in interest, right? So that's where the 4% comes in. So, it's the same, it's savings per month, you can get a annual savings. And then the annuity factor. So there it's applying that to the savings. As an annuity. So there's different ways that you could do it. This is using that table B, that every year I save $720, and it's those savings I can be, investing at 4%.
And I guess that's where did you get the 4%? Do we use that? Because it said if you buy the cheaper, you invest the 3,000. So you use that 4% for that question as well?
Yeah, it looks like it. That's what we did there. Yeah. Yeah, so I mean, it's you can invest the 3,000 different in a certificate of deposit, but so it's not even looking at the $3,000 difference. It is looking at the savings. This is why I don't teach the financial part of it. So it's looking at the savings. So you're comparing, okay, I have $3,000. This is where, for me, having that little timeline, that like mapping it out, is helpful. So the output is the $3,000. The input, if I didn't go with the Chevy, would be the $720 per year. So, or vice versa. The outflow is, the 3,000. And so you want to say, well, that is over a 10-year period. How much would that additional savings matter to me now? And that's where you apply this annuity factor. So if I were able to save $720 a year at 4%, right now, that would be worth $58.40. That makes sense. This is why I don't teach this. It's hard. Okay, who can make sense of this? How did other people go about doing this? Anybody?
I did something similar. I just wasn't sure whether to use the 4% or not for the part B.
I agree, Joanne. That was where I was hung up as well.
Right, because it specifically says in the example that it's about the certificate of deposit if you don't use the 3,000. But it's just saying that this is a 4%, that this is the rate that you would be able to get. And so it's just a number that you're able to use to kind of get a sense of whether or not there's more value to that savings. And then there's a whole bunch of commentary here. This was written up by our previous instructor, and so who had a much better sense of all of this stuff than I do, obviously. So I recommend that you read through this.
Okay.
I'm trying to, darn it, I don't have that with me. So I'm going to stop sharing for a minute. Oh, there's that. There we go. And the reason I'm doing that is because I want to look at the exam itself and I don't want you to see it. Because I want to see how much is in there. So with the financial side of things, there is one a word problem that's similar to this. Can you see my doc? You can't see mine.
We can see all of it, Pam. Thank you. Oh my God, guys, did you catch that one? All right, you take a picture, Rachel, you keep going on that one, and
Joanne,
you know
you're
what? I
you're
have,
bordering on not funny.
I need some humor here. I got something. I got something.
All right. So there is one word problem similar to this car problem where you just have to look at all the information. I recommend mapping it out. I mean, for me, that really is helpful. What are the inflows and the outflows? What is the percentage rate? What is the expected life? And then, you're going to go through the financial data. I think that those tables are really helpful, and it's a matter of figuring out which is the right table to use and why. But other than that, no, there's a couple similar questions like that, looking at net present value and simple payback. So, I think what you need to do is just go back to that module 9 in the online materials and just take another look at that. You should feel free to reach out if you have questions. And yeah, I mean, I'll do what I can to share with anybody. If I get a question from anybody, I'll share it with everyone else. All right. Thanks, Carrie. All right. It is 3:30. Thank you guys for hanging in there. Thanks. Bye, Rachel. Good luck. I'll see you next week.
Thank you. Thanks for
Thanks,
everything.
Jen.
Thanks. I hope you feel